Today we're going to be on Desmos, and we're going to look at real life situations, again, where linear functions, so lines that are straight or functions in general, come in handy in occupations. So the first slide here, it says move the plane so it lands safely on the tarmac, which is this strip right here. If you move the airplane, you can only move it up and down. A hint for you is at this airport, a safe landing is going to be straight down the middle of the runway. So I think maybe about there. If I hit submit, oh darn, I was off. It means my plane did not land safely, but that's okay. We'll be working in other precise ways to land the plane correctly. If you click the next slide, it says a line can help. Lines can help us be more precise. So the path for safety landing of the airplane follows y equals 15 minus x. Now remember, this is similar to our y equals mx plus b. Just in this case, it's flipped backwards. So I know that this 15 right here is actually going to be my y-intercept. One, because it's not attached to x, meaning it's not my slope. And two, it's by itself, essentially without an x. So what I'm going to do is I'm going to drag my plane all the way up to 15 here. And I'm going to make sure it hits my y-axis. This negative x, remember there's a 1 between this negative and this x, meaning it's decreasing each time by 1. So let's see if we got it. Our airplane is at approach. Woohoo! We landed it safely. And if I wanted to retry and show you, so if I would have said it was at -1 or something like this, I definitely would not have the best airplane so far. And it'll tell you to readjust it. So if you click the next slide. So for this exercise, we're going to be, for the next couple screens, we're going to write an equation that will safely land the plane. In the examples on the left, only the red traces the path of safe landing. As you can see here, this red line goes straight through the middle, or the dashed line, the center of the tarmac. And if you click it, you can see that the y-intercept is at 6, the x-intercept's at 9. You can see over here, and green is something different. So we want to land the plane safely in the middle of our tarmac. So this is what I have so far. This is our startup, where I have to change one number in the equation below to land this plane safely. So let's see. If my -7, meaning my plane is down here at -7 on my x-axis, and I have a slope of 2, this is what that line's going to be. So let's see. I think let's change our y-intercept. Okay, that didn't work. So let's change our slope. Let's change it to 1. Okay, so it's getting steeper. Let's change it to a half. That's pretty darn close. Let's see. Let's try a third. No. Try a fourth. No. So let's try a half. If we hit submit, 1/2 x minus 7. Woohoo! We landed the plane safely! Yay! So as you can see, we rise from one point. If I start my y-intercept here, -7. If I rise 1 and run 1, 2, I'm going to hit another point. And if I rise again 1 and run 1, 2, I'm going to hit another point here. And so on and so forth. So then now we're actually not given the line to help gauge us. But let's see. I know that it's y equals, it's going to be a negative number. I'm going to just put -1x plus, and since our plane starts at 15 here on the y-axis, I'm going to do plus 15. Well, let's see what happens. Pretty steep. And in order, in order to edit your response or try again, we're going to hit edit response. Let's try a -3. Nope, still super steep. So maybe they have a fraction. And the plane came back because it didn't land. Let's try -1/2 again. Nope. Okay. close. We got closer to the tarmac. Let's try it negative 1/3. Nope, still steep. So I know it's going to be negative. Maybe let's try like 1.2. Nope. Okay, so let's try a larger number. -5, why not? Even more steep. So I know it has to be larger and wider. So I know it has to be less than -1. So I know that 1/2 was pretty close. Maybe let's try 2/4, which would give me a half. So just to verify, still a little bit off. Maybe let's change the bottom fraction. And what we're doing here is we're just trying to get as close as we can. I can also see that this point right here is going to hit our graph, right where my cursor is, right here. So 611. And if I have 611 and I go up 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, I have 4/6. So starting at this point right here, 611, and I'm going to get to 0.15. I went up 4 and over 6. So my rise was 4. My run, since I was running towards the negative numbers, is negative. So I can actually reduce this by 2, and it should give me, oops, -2/3. Okay. Let's try that. Let's try 2/3 and see what happens. Oh, hey, look at that! That's pretty awesome. We landed the plane safely. So what mathematicians and even pilots and everything use is we can find a point that might be in the center here. I could have chosen this point right here. I could have chosen that point. I could have chosen clear points that I could see. But we can definitely predict what it was going to be. And we saw that it was between 1/2 and 1/3, so 2/3. Oh, snap. All right, so Allie and Rowan were trying to graph the blue line shown below on the left. Only one of them is right. So let's see. Allie entered the equation 2x minus 8. Rowan entered the equation y = 8 minus 2x. So what's really cool about this is I can actually flip around Rowan's equation so it looks similar to Allie's. And what I mean by that is, instead of it being y = 8 minus 2x, if I flip these two places, because remember, we have y = mx plus b, and this is our slope, and this is our y-intercept. If I flipped it around, I'd have -2x plus 8 for Rowan's. So what I can see here is now I can compare them. Well, there's one that's clearly right, but I can definitely tell by looking at the y-intercept right here. If I look at the y-intercept, I can clearly see that it is a +8, meaning my b needs to be a +8. Now, if I look back at the equations here, I can see that Rowan's has a +8 for his b, while Allie has a -8. So Rowan is correct because he has a positive y-intercept. Okay, so that's why he is why Rowan is right. He has a positive y-intercept, and or you could have said that the slope is negative, while Allie's was positive, meaning it would be increasing from left to right, not decreasing. Make sure you hit that share with class button, and there will be more answers down there for you. And that is it. So there would be a class gallery if you didn't miss class, or if you just wanted to review what today's lesson was. But you are all set now to move to doing your checkpoints.